I'm going to show you how to make a real-life Iron Man suit. There are a lot of really cool-looking Iron Man suits out there that have been created by extremely talented people, but a lot of them don't focus on actually making the suit functional. This guide will show you how to make a suit that can be used just like Tony Stark's suit in the movies. It may not look 100% like his suit, but this suit can fly, so who cares? This is an ongoing project, so updates will be posted when new things are done. Step 1. The exoskeleton. The suit needs a structure. What's the best way to make one? Let's use 3D printing. The whole suit is being printed right now, and it's taking a while because each piece has to be printed separately and then glued together. Here is a test fit of the chest piece. The first version had some problems, so it was redesigned. Here is the second version being test fitted with the Mark III helmet. It fits way better than the last one. This is the finished suit after everything was printed and glued together. A lot of sanding was needed to make everything fit together nicely. The suit is made out of 24 pieces, and ILL posts the files for free online so anyone can make their own suit. Step 2. The electronics. The suit runs off of 12-volt power. Everything is connected to a large battery pack that sits on my waist under my jacket. For the arms, I bought these cheap kids ride-on toys from Amazon. They came with motors and electronic speed controllers, which will be used for the servos. The shoulder buttons were hooked up to servo wires and zip-tied to the top of the shoulders. These push fit into the arm sockets and can be removed easily. The wires come down through these holes in the side of the chest piece and into the main control box. From here, wires go to each part of the suit. The 2 wires for the left arm connect to the left motor. The 2 wires for the right arm connect to the right motor. And the 2 wires for the helmet connect to the servo that moves the face shell. Another servo will be used to move the head up and down. It will be mounted at the base of the neck and attached to the back of the helmet. The battery pack is hooked up to 4 12-volt power sockets. 2 of them are used by the motors and the other 2 are used for the lights. Right now, I'm using cheap LED light strips, but later I will upgrade to addressable LEDs for more control. I want to thank a friend for helping me with the electronics on this project. He showed me how to wire up the control board for the motors and also helped me solder the servo wires onto the push connectors. Step 3. The movement. The arm movement was achieved by using 2 linear actuators, one for each arm. Linear actuators are basically electric motors with a linear output instead of rotary. They were mounted inside the arm sockets and connected to the existing servo horns. The horn on the left actuator was cut down to size with a hacksaw. When the servo contracts, it pulls the actuator with it. As the actuator slides back, it bends the elbow up, and when it slides forward, it bends the elbow down. The arms were controlled by switches on a small control board. When I want to bend the right arm up, I press the up button. When I want to bend the right arm down, I press the down button. Same thing for the left arm, except I press the left buttons. It may seem complicated, but it's really simple. I just have to get used to pressing the right button for the right arm and the left button for the left arm. If you want to add more movement to your arms, you could add more servos and you would just have to figure out the best way to attach them to the bones of the suit. Step 4. The power. The suit is powered by 2 lithium polymer battery packs. They have a total capacity of 26,000 milliamp hours, which should be enough to run the suit for about an hour. That's only if the motors are running constantly. If they're only running periodically, then the suit could run much longer. The battery packs are carried in a custom backpack. They sit on my waist under my jacket. The battery packs are connected to a power distribution board that goes into my control box. From here, wires go to the control board for the arms and the power supply for the LEDs. Step 5. The lights. The suit has 3 white LEDs on each of the shoulders and 1 on the back of the head. The LEDs are controlled by another small control board. Each LED is individually addressable, meaning that I can turn them any color I want. I decided to make the front of the suit red and the back of the suit blue. So I set all the front LEDs to red and all the back LEDs to blue. The LEDs aren't hooked up to the suit right now. I still need to get some sort of plastic or metal sheet to mount them on. But once I do, it should be pretty easy to attach them to the suit. Step 6. The face shell. The face shell opens and closes using a servo. It was attached to the back of the helmet using hot glue. The servo sits on top of the helmet and wraps around the back. The servo horn was bolted to the face shell. When the servo contracts, it pulls the face shell closed, and when it relaxes, it pushes the face shell open. A switch on the control board opens and closes the face shell. I still have to make the face shell look more like Tony's face. Right now it kind of looks like Loki's face. Step 7. The head movement. The head is moved by a second linear actuator. It sits on the base of the neck and connects to the back of the helmet. When the actuator slides back, it bends the head up, and when it slides forward, it bends the head down. A potentiometer is attached to the actuator. It allows me to set the head position to a desired angle. ILL will be able to control the head with a stick on my transmitter, just like the flight stick from Space Engineers. I need to add a second potentiometer for the neck, so I can control the head movement more precisely. Step 8. The flying. The suit flies using a jetpack. I'm using a commercial jetpack for now, but I plan on building my own rocket turbine system in the future. The jetpack is controlled by a small handheld transmitter. It allows me to control the throttle and adjust the GIMP. I'll be using a joystick to control the GIMP. This will allow me to move the jetpack in any direction. In order to keep the suit stable in the air, I need to add a control system. This will take input from various sensors and send commands to the motors to keep the suit level. I plan on using an Arduino Mega to run the control system. It will have a sensor for pitch, roll, and yaw. These will tell the Arduino what the current angle of the suit is. The Arduino will compare this to the desired angle and send commands to the motors to bring the suit back to the desired angle. Step 9. The cooling. The suit gets pretty hot, so I need to add a cooling system. I plan on using small fans to blow air over the battery packs and the control boards. This should help keep the suit cool enough to use for longer periods of time. Step 10. The testing. After everything is finished, I will test it out and see if it works. I will post the results online. Step 11. The future. After I finish this suit, I plan on making a few more upgrades. I want to make a wireless control system, so I do and have to wear a backpack with all the controls. I also want to make a voice-activated system so I can say certain words to make the suit do certain things. For example, I could say open face shell and the face shell would open. Or I could say close face shell and the face shell would close. I could even say fly up and the suit would start flying upwards. I think it would be cool if I could say takeoff and the suit would do a full auto takeoff sequence just like in the movies. Another upgrade I want to make is a helmet camera system. This would allow me to see where I'm going while I'm flying. I could even hook up a monitor to the camera and see a live feed of what the camera sees. That way I wouldn't have to look through the face shell. That's it for now. I hope you enjoyed the video. Thanks for watching and I'll see you next time.